thank them for coming. I'm delighted to have Adam Storeygard here for our brown bag talk this week. Adam is professor of economics at Tufts, and he's visiting the Department of Economics this year on sabbatical, I guess, not sabbatical. He started, I just learned his interest in demography started when he spent some time at Columbia with our own Deborah Balk, a graduate of this program. And then he did his economics degree at Brown. He works on many topics at the intersection of economics and demography, including urbanization, climate change, transportation. And so we're just delighted to have him here. He's here till the end of May, so if you want to hook up with him, he's here in the economics department. And take it away.
Great, thanks so much. So I do feel like the Berkeley demography has influenced me through advisors and mentors throughout the year. So it's really nice to be here, and I look forward to your feedback on this talk. I'm an economist, so I welcome interruptions, but I've been around enough pop centers to realize that I need to leave some time at the end for questions from less impolite disciplines, perhaps. So I'll try to do that. So this is joint work with Vernon, Henderson, and Beichmann, and we're looking at climate change and urbanization in Africa. And so we think that this is an important set of issues for a few reasons. So one is that Africa is less urbanized than most other developing regions, and that leaves a huge scope for urbanization. So the UN projections suggest that of the approximately 2.5 billion addition to global population we expect in the next 35 years, a third of that is going to be in cities in Africa, right? And so where they go, where that new population goes is going to have a lot of impacts, and we think that it's been argued that climate may have some effects on that. Right? It's also a region where we have a lot of grain-fed agriculture, employing a large fraction of the labor force, and so this is important for rural livelihoods, right? And it's also a region with declining moisture that I'll show you a bit more about in a minute. In some places are already quite dry and marginal for agriculture. While we don't know exactly, we don't know for the smaller the region you get, the less we know exactly about future trends of climate. But we feel in general the projection suggests suggest warming across the region, and more drying is also possible. So this is a map of, the climate measure we're going to use is what I'm going to refer to as moisture. And so this is precipitation divided by a nonlinear function of temperature, essentially accounting for the fact that when it's hotter out, water dries up faster and is less useful for agriculture. This is sometimes known as an aridity index, but because the higher numbers mean wetter, we sort of rechristened it as moisture. So in this, from the 50s and 60s, this is what the map looks like. The key, a useful dividing line is 1, which is between the two sort of blue-gray shades and the redder shades. And the idea is that at 1, you have rainfall is replacing the water balance is water has sort of been balanced in the sense that there's as much coming in as going out through evaporation.
So if it's not at 1, what happens?
So it's evaporating away faster than it comes down. If it's above 1, then you expect runoff in the form of rivers and things like that, right? I mean, this is a very, we're doing it over these large scales. So hydrologists would be doing fancier things, but that's sort of the broad rule of thumb way of doing that. And this is what changes have looked like between the 50s and 60s and the past 2 decades, right? So the yellow is, every projector does this slightly differently, but the yellowish regions have little change within about 10% up or down. All the orange areas have seen drying on average by between 10 and 50%. And the places that you see green getting wetter started out from such a low baseline that we're less concerned about them here. We're thinking about the region south of the Sahara. Now, if we look at that by country and across all of the years in our sample, things get very noisy, as is often the case with climate data. But if you squint, you can sort of see a general downward trend. This is across, I think, the 29 or 30 countries across that. So the questions we wanted, more specifically what we want to think about today is what the effects of the local effects of this reduced moisture is on two quantities. So one, the urbanization rate, so just urban over total population at the district level. For a demography audience, it's important to point out that we're doing this purely on net, right? So we don't have good data on the components of population change. I may perhaps too much talk about this in terms of migration. We think migration is a very important component of this, but we can't distinguish that from that mortality. The other outcome we're going to look at is local total city incomes, for which we'll be using satellite data on lights at night as a proxy. And unfortunately we can't, so ideally you'd want to get at some measure of welfare, you'd want to divide the two, right, to look at income per person. But as you'll see, the timescales we're operating on are very different for the two exercises, so we can't actually do that directly. And the answer we're going to find is going to depend critically on two sources of heterogeneity, right? Or especially the first one, right? So, and that first one is the propensity or ability of local cities to produce tradable goods. In other words, the extent to which they're not entirely dependent on agriculture. And the other one we test and find some weaker evidence of is that you might expect to have a stronger effect in places with a baseline moisture level that's lower, right? So if you're already marginal for agriculture, you might expect a bigger impact of drying than if it's a wet place in the first place. Okay.
And what is your hypothesis on two? The first one, the implication is that people will be driven from the dry areas into the city.
Sorry, so I was going to get that but I should just say it now for so basically we think the difference is that so if you don't have we think that many cities in sub-Saharan Africa are essentially agricultural trading centers without export manufacturing, export even outside of their city, right? And so in that case, the local city is hurt just as much as the surrounding farmers, right? So if you don't have this export from manufacture, then everyone's hurt, and so so that there's going to be very little impact on urbanization at all, and income will go down. If you do have this export from manufacturing, then we do expect people to be drawn in, and potentially for income to go, for total income to go up, right? Well, we're not going to focus on per capita income, which our simple model would suggest that that ultimately you can't get helped by this, but that the overall population, overall income would go up. So just to summarize our results, we find that this is true in the way I described, so that this declining moisture has driven people out of agriculture and into the nearby towns within the district or province, but only for districts that are already industrialized. So, based on a particular measure of industrialization that I'll talk about, but not otherwise, which is the majority of our sample. And the magnitude of that effect is quite large, right? So for the districts that are most likely to have some sort of form of export manufacturing, based on our proxy, a 1 standard deviation decline in the annualized growth in moisture is going to decrease. Is going to reduce the growth rate of urbanization by about 50%. And then for arid countries, our measure there, the effect seems to be even slightly larger. For our income outcome, right? Again, the important variation is whether local towns are likely to have this manufacturing orientation to external markets. And if they do, then this reduced moisture is going to increase total city income essentially by drawing in a new labor source that the city can absorb, and the elasticity of total, and so the elasticity of total income growth of our total income growth measure, nightlights, with respect to rainfall is about negative 0.17. In other words, for a 1% decrease in rainfall, we expect a 0.17% increase in income. On the other hand, if we do not have this manufacturing orientation, we see essentially no effect because the moisture declines are going to be very heavy. This is a very partial literature review. I think that you would be very interested in knowing sort of other things we should be talking about in demography literature. There is the key paper in economics that this relates to is looking at cross-country data and is arguing that climate has been an important push factor in African urbanization overall. But they're looking at national data, whereas we're actually able to compare across regions within the same country that have had different, potentially different climate experiences and different urbanization experiences. We think that's especially important because more migration in Africa is local. And we also can do a little bit better job at the time. Now, I just have this one paper from the sort of microdata migration literature from Burkina Faso, looking at the first moves of rural residents, right? And that suggests a modest relocation to urban areas in bad agricultural times, but actually a bigger effect on relocation to rural areas, which we would not, we would find hard to pick up in this context. But it's not, but because it's looking at these rural residents, it's not getting at evidence from people who left the rural areas. There's and I'll just leave it said, there's also, of course, vast literature on climate change in general that this relates to. So for those of you who are who like economic models, there is a small model in the paper, but I think I will not go over that in full. The basic, I won't go through the math of it, but the general idea is that we're thinking about a local district as a small open economy with rural and urban populations. We're thinking about a context of perfect mobility. You could build in mobility frictions without too much difficulty. There's a rural sector that's producing agriculture for export outside the district, and then there's a town or city that's going to have a local service sector, think sort of trading between farmers and manufactured goods coming in from a big city or from abroad, and then possibly an export manufacturing center. And the idea is that, and the other critical thing about the model is that increased agricultural productivity is actually going to induce people to stay on the farm in this kind of model, whereas in other kinds of models might use the opposite, have the opposite assumption and come up with the opposite results. So the predictions of the model are,
Is there I don't know, a food market so that there are imports from abroad and so on? If people are approaching some sort of biological subsistence level, are there things they can do, desperate acts they can take?
So yeah, so the way we get food in is by exporting agriculture. So when you have manufacturing, you're getting food out, but in you're getting food in, right? So in the absence of trade, we don't. That isn't built in the model.
So the urban people can buy the food with the exported industrial goods, but what about the rural people that drought is, keeping from growing enough even for themselves?
So the goods market is so within each local region, within the local region of the model, there is a goods market that they can. So there's a price of the agricultural goods, but if the farmer, that's going to be their only. Without anything to export from the region, we wouldn't have anything coming in. There's nothing to trade out. I mean, there's many different models one could fit to this. This one is just one that happens to sort of fit with our results. So I don't want to make too much of the model. But what comes out of this model is sort of what I've been saying, that if you have a manufacturing sector that's not too small, right, then decline in moisture is going to lead to an increase in urban population and an increase in total city income. And that effect's going to be bigger when moisture influences agricultural productivity more, which we think of as in drier places, places that are already drier. Conversely, if the local urban area has no manufacturing sector or a very small manufacturing sector, there's a smaller and ambiguously signed effect on city population. It could go a little bit up or down. And broadly speaking, if moisture declines, the city income is going to decline, but really just more slightly.
So I'm in some town that doesn't have a manufacturing center, it, I guess, has some administration, schools, market. As it gets more people, price of labor goes down, and it may be worthwhile turning on a manufacturing sector.
So
is that part of?
So that's a very, so that's one thing we're not addressing in this moment, in part because we don't have data to think about when. So as you'll see, we have a very crude idea of when a city might be a manufacturing sector or not, for looking across such a broad region. So no, I think that's a critical component that the model's missing, and sort of in the back of your mind, you might have some of these sort of, that's certainly potentially going on in some places, but it's not something we can address empirically. So just in the back of your mind, you might want to be thinking about why certain places are going to be manufacturing or not. We're leaving that totally exogenous in the model. This could be, for many different reasons, that the cost of effective labor is falling. You have better education, for example. The increased price of oil manufacturers is making it sort of more worth it. Easier to definitely export from a small city, or in some of my other work has looked at potentially effective transport cost reductions and sort of drawing these cities into manufacturing. But that's not something that we're going to really be able to address here. So for the urban population question, we're going to be using gridded temperature and precipitation data that's interpolated from station data. And then the main data exercise for this paper was collecting district or province level urban and rural populations from 89 censuses. And because each country carries out censuses in different years, we have a highly unbalanced panel. So what that means is we're going to take a first difference. We're going to for each of our for both our climate measure and population, we're going to take the annualized difference between a given census and the following census. Now, for a key component of our story, of course, is this idea that some cities are more likely to have a manufacturing sector or not. It's very hard for trying to look across 30 countries to try to look at a large enough sample. It's very hard to get consistent information on this. So the best we can do for now, we think, is to look at this this Oxford Economic Atlas Africa from the 1960s that plots out cities with a manufacturing presence in each of 26 different industries by city. And we collapse those 26 industries into, we think about some of them which are primarily agricultural processing, which may be less important for this story, right? So if you're just milling the local grain, versus more, what perhaps inappropriately we're referring to as modern industries here, doing other things that are less directly related to agriculture. So that's going to be sort of the critical, what drives differences across cities. We're using this, requiring this data means that we're restricted to places that have at least 2 reasonably reliable censuses with relatively consistent internal boundaries across census years. And within each of the subnational regions defined by those boundaries, we need an urban and a rural population. So that gives us data for 29 countries and 89 censuses, about 350 districts or provinces, and on average 2 intercensal changes per district, meaning 3 censuses per district. We have pretty good coverage in places like in dry places like the Sahel, but there's several countries where there's no good data. So Angola hasn't had a real census since 1975. So this is our sample, colored here by the number of censuses we have. In the sort of lighter colored within country boundaries show the size of the regions we're comparing. And then here we have our industry measure coded categorized. So most of our regions have none of these industries, right? And so for them, we predict a more limited impact on urbanization rates from climate change.
Sorry, just a quick question.
Sure.
And I apologize if I covered this earlier. You're using the industrial data from 1965. Are you comparing it to more recent industrial data?
No, so we wanted something for the beginning. We don't actually have a reliable subnational measure that we can apply across a large set of countries. We do want something from the beginning of our period so that the idea that it's not being affected by the changes that we're looking at for now. So on the other hand, of course, I agree that this situation has changed since the 60s, right? So it's not that I'm saying that the picture of the 60s is precisely what's happening today. We think it's useful to look at that as sort of a proxy and one that's exotic, one that's not being affected by subsequent. So the regressions we're going to run are looking at the annualized change in urban population share between two consecutive censuses. Again, so annualized, based on that, because our censuses are between 10 and 17 years apart. We're going to look at that as a function of the annualized change in moisture between census years. We're going to smooth by sort of 3 years at each census to get rid of some of the noise in the moisture data and to allow for some averaging there. And then we're going to look at that relationship, but then add in the moisture change interacted with our industry measure. Our industry measure and our baseline moisture measure, right? The two forms of heterogeneity that we think are important. Because we have multiple regions per country and multiple years, we can also include a country by year fixed effect, right? So so we have a dummy for the Kenya 1989 sample and a dummy for each other country year, right? And so that allows us to control flexibly for country trends, including, for example, changes in the definition of urban, right? So that we expect is going to be applying to the whole country, and so that gives us some hope that that's not driving our results. So that means the identification is going to be coming from within country variation in growth rates, right? Not across countries directly in that sense.
Could you just say a bit about the relationship between population growth and urbanization? Your measure of urbanization. The countries with faster growth rates have increasing U.
So if a country's urban and rural populations are both growing at the same rate, then our U would be 0.
Right, but what's the empirical? Do countries that are faster growing, do they have, or is there no general relationship between population growth and fraction urban?
I have to consider that. So we're concerned about whether this identifies the relationship we're interested in, this regression, and we're concerned for a couple reasons. One, just because what we're doing is pretty demanding on the data. We're restricting ourselves to within country variation, so it's not obvious, first of all, that we have enough variation there. The other issue, of course, is we think that that moisture trends are not being driven by human activity during this period in this region, but by local human activity. But it could be the case that they're not, in the sense of a randomized trial, that there's not balance across the places where moisture grew, where it got a lot wetter versus not, across other variables that we think would be important in driving urbanization, right? In practice, we find that our moisture change measure is not correlated with these other factors, so initial climate, initial urbanization, who your colonizer was, so the kinds of things we can measure. The one exception is there is a correlation with distance to coast, and so we control for each region's distance to the coast in these regressions. We also control for the initial level of urbanization in case there's convergence in that. It doesn't seem to matter. Let's skip through that. These are the summary statistics. I guess the things to note here, the average moisture growth is slightly negative, consistent with that overall downward trend, but very noisy. And about half our sample is wet, using the definite versus dry, using the definition we use in the so in column 1 here, I'm showing this. First of all, I'm showing a baseline regression of the change in urbanization on change in moisture without any heterogeneity, so not interacting with this baseline manufacturing measure or moisture measurement. And there you see there's no, we see no relationship there, right? So there's it's small and insignificant. So where things start to be somewhat more interesting is in column 2, where we're interacting this change in moisture with our manufacturing intensity measure. And so this variable is a little bit convoluted, so I'll try to walk you through this. Okay, so the idea here is that we have a count of the number of industry of these modern industries in each region. Okay, and the maximum of those is 8. And so we're going to take 8 minus that number and call that sort of the propensity to be just an agricultural district. Okay? And so we multiply that sort of propensity to be agricultural by the moisture share. And then the way to think of these two variables is that -1 is the effective moisture change in those regions, in the regions that have this zero agricultural share, the regions with the most of these manufacturing industries at the beginning of the sample. Right? And then for each of those industries that a region lacks, we subtract off about 0.12. Okay, so that by the time you lack all 8 industries, the sum of these two coefficients, the -1 plus 8 times the 0.125, you get back to about 0. So for the majority of the regions for which that do not have any of these industries, the expected effect is 0. I'm happy to go through that one, or try to. If anyone has any questions about that, please speak.
So, modern industries are counted. Can you remind us again of the unit analysis? It's
sure. So the unit of analysis, yeah, is a district or province. So the average.
And how many such districts or provinces are you within? You've got about 12 countries.
So we have about 29 countries and about 360 some districts. So about 12 or 13 districts per country on average. And so the units of the industries is a count of the unique essentially the variety of industries you have in that.
And that was as of 1965.
Exactly. Yeah. So it's, I mean, this by any standard, this is a rough. I mean, I don't want to. I recognize this is like a rough measure of that, but we think that this is sort of the best we can do in a way that is not that is exogenous to the process.
Yeah.
So that's the idea here. In column 3, we're doing the equivalent exercise, except instead of using modern industries, we're using all industries, right? So which includes these agricultural processing industries, and that means that the maximum is now 13. The effect for the most industrialized regions is pretty similar, slightly larger, and then the impact as we take away each region, we move that impact back towards 0, so that by the time you lack all 13 industries, you have an overall effect of 0.
Why do you think the initial share urban has a big effect?
So So I guess there's so that would be consistent with mean reversion, right? So mean reversion. So first of all, so there's some places that are already extremely urbanized. So places that are extremely urbanized, that are already 80% urban, are less likely to increase their reversion as fast. That's what it is. Let me just say here just briefly, I won't go into all the numbers here, but if we play around with sort of, we trim the sample with outliers from the sample, that doesn't seem to be driving much. The smoothing is somewhat important, so smoothing across the first 3 years and the last 3 years of each intercental period. Things look fairly similar if we smooth across 4 or 5 years, but it starts to get noisier. And results start to get smaller if we smooth over a smaller period, which we think is reasonable in the sense that we don't think people are necessarily making choices based on 1 bad year or 2 bad years, but more we're trying to think about overall changes. Let me see. We don't see any independent effect of your neighbor's moisture, so we're limited again on average to 12 districts per country, so that it's hard to get much independent variation in your neighbors without having that variation in yourself. So we may not have enough variation to look for that, but we don't see that. If we replace our moisture measure with the precipitation measure, we get results that are very similar. So it does seem to be more about sort of precipitation changes than temperature changes. Let me see. Here we try I'm now doing the other kind of heterogeneity, so looking at whether places are initially dry or not. And so the way to read column 1 here is that if you are dry, if you are a place that was dry in the 50s and 60s, you see this negative impact. Whereas if you are wet, the impact is the sum of these two variables, right? You get your moisture level plus your moisture level here times the fact that you're wet, so that the overall impact is slightly positive, but not significantly different from in column 2, I'm combining the two sources of heterogeneity, and the only form that really seems to matter now is the industry is whether you have manufacturing here, right? So the interactions with the interactions with whether you're originally dry or wet do not actually seem to make a difference.
But the coefficient on moisture times wet is non-significant at large.
Right. No, that's true, right? So it could, and it is in the direction we expect, right? So it could have some impact, but it's not business to measure. That's true. We also looked at using countries as a unit of analysis, both just to see if this is we saw the same patterns, and also to look at, instead of urbanization rate, the primacy rate, right? So especially in this region, you have a lot of capital cities that are very large. But this, of course, shrinks our sample size down to 89 census years, so it's about 60 some odd change pairs. So not surprisingly, we don't really see any impact on primacy, in part, if for no other reason, because of a very small sample. Let's see. We looked for several other forms of heterogeneity that you might think would matter for this relationship. So for example, if you have access to irrigation, that might mean that less rainfall is, having less rainfall is less important, right? If you have access to other forms of water for your crops. We have a very rough proxy for irrigation, but it doesn't really seem to have an effect. That's not so surprising for this region because in general you just have much less irrigation here than lots of other regions within the developing world. We also looked at a couple measures related to soil. So for example, different kinds of soils are able to store water better than others, and those didn't seem to matter. And we also tried to get at, we have this rich time series of climate, right? And we're just looking at the sort of the beginning and the end of each intercental period. And you might think that it's not that change between the beginning and the end of that period that matters, but rather how variable the climate is in between might matter as well. We don't find any evidence of this, but it's a very hard thing to pull out of the data, right? So it's possible that exists, but we don't find any evidence of that. So none of these forms of heterogeneity really seem to matter for us. The other one that I didn't have a chance to put on the slide yet, because we were just doing it, is that there's been a lot of work about sort of climate and conflict, especially in sub-Saharan Africa. And while that doesn't seem to be driving our results as well. If we look at, if we control for and interact with various forms of internal conflict, our results look very similar. So it's not that conflict, it's not exclusively that our effect is not being driven by rural conflict driving people into cities.
So this is a very general question, but in this fixed effects type of setup, why are you so worried about heterogeneity? You've already done your differences within places, plus you have these country time-specific fixed effects. So I thought your answer to anything was going to be, I mean, if we said population growth, or if we said religion, or anything you said, we said, well, we have fixed effects. So what is there a reason to be?
Well, I think so. Part of it is so we see this net effect. We see an overall net effect of 0, right? So on average, there's no effect, right? But then we find we find a form of heterogeneity that we think that disperses some results that we think are interesting and consistent with the theory, right? But it's these are other forms of heterogeneity that but first of all, those effects could actually be driven by a different form of heterogeneity that we're not controlling on, right? And second of all, once we found one form, there might be other forms. There might be other. We in some sense we care about where this might be having. We care about if this isn't having an impact in some places and not others, right? And these are ones that sort of theory would tell us that matter, right? Like if you have, if noisier signals should might be a problem, or having irrigation might make less trouble. So yeah, I think we.
So these are kind of interactions.
Yeah, these are interactions with the. Sorry, when I say heterogeneity, I mean these are interactions with everything else. Right? Sorry, that should. So each of these things here, I'm individually interacting with everything I had before. So that's another thing, of course, is that we're getting into sort of triple interactions here, and so it's harder to apply these concepts. We don't see anything else. I want to, I guess, just briefly mention the other the local city income exercise. I guess to briefly, so here before we were looking at intercental periods since from the 1960s to the present. Now these night lights data exist only from 1992 to 2008, right? So it's a very different time frame. In previous work, my colleagues and I have shown that these lights data are correlated with changes in these lights are correlated with changes in economic activity at the country level. And we've seen some subnational evidence for China and elsewhere, right? And the issue, of course, is that we don't have good city-level income data for sub-Saharan Africa, and so this is a proxy that we think is useful. We also have for this time period rainfall data from satellites that we think are better for this context because they're less likely to be correlated in the sense that they're not just being interpolated across weather stations. And so because we're getting essentially all our data from space, we can look at all of sub-Saharan Africa. So we're looking at almost 1,200 cities in 42 countries. And so this is just we define our lights. We've defined cities as the envelope of lit areas across all our sample years. So for a set of light outlines for different years, these greenish outlines, that is then a city, and that is a city for which we count the amount of light being emitted into space at night on average for a year. And then we calculate rainfall within a 30-kilometer catchment of those lights. And we regress changes in lights on changes in rainfall. We only, with these better rainfall data, we don't have a corresponding temperature measure, so now we're just using lights, rainfall and not moisture. So we're regressing changes in lights on changes in rainfall, interacted with the two forms of heterogeneity that we discussed before. Because we have so many cities and so many years, we can include year fixed effects, controlling for sort of arbitrary overall trends, as well as city fixed effects, which in a differences specification is equivalent to having individual city-specific time trends. So essentially, you can imagine each city being on a different trend, and then we're trying to pick up deviations from that trend being driven by rainfall. And so the way to interpret this table is actually is very similar. We have the two forms of heterogeneity we did before, and now in this later period, we can use national measures of the agricultural fraction of GDP, the share of agriculture in non-natural resource GDP, non-sort of oil and non-mineral GDP, right? So in the early period, we didn't even have that, like these national measures of the share of agriculture. And the idea here is that similarly to these, the maximum minus minus the number of modern industries, having an agricultural share or a national agricultural share over a certain amount is a proxy for being less likely to have a manufacturing sector. So once again, there's no effect overall. In places that are in places that have a low share of agriculture in GDP, we see a negative effect. So less rain means more lights, consistent with our story of that sort of driving people into the city. Whereas if you add the two together, you get for places that have less manufacturing intensity, you get a net effect of zero. I should really probably end there and leave some for.
Let me just
Sure.
go back to what you were talking about.
Sure.
I think of this is change from year to year in rainfall.
Yep.
Yeah, so I think of that as fairly high frequency, short.
Yeah. In a way, it's more surprising we'd get something on such short term.
Yeah.
That was surprising.
But I'm thinking of the lights as reflecting, built housing stock and streets with lights and things like that would change more slowly and not reverse quickly and so on. So if you have annual data, it might make sense to have some sort of distributed lag or some way of filtering out the shorter run stuff and focusing on the longer run.
Sure. So we do. We see limited impacts of lags, which we also found a little bit surprising. I mean, in comparing lights with GDP, we see little effect of. So I think your model of lights would say that there's sort of a ratchet, right? You build a street light, but then you don't take it down, right?
Yeah.
And so we don't. We find that. So in looking at the national data where we have actual GDP data, we don't see much evidence of that, right? So that increases and we see a pretty symmetrical effect of increases.
The lights go up and down.
Exactly. Yeah. Not.
Okay.
I mean, we don't see much, but we also don't see GDP decrease much either, right? So so that, I mean, it's perhaps surprising when we don't see much evidence of that, but we could certainly do a little bit more to clear it.
Okay.
So I would just say that to conclude, there we go. We see that these declines in moisture that we've seen over the past 50 years seem to, our results are consistent with those declines in moisture, encouraging city population growth in places that are most likely to have manufacturing, perhaps somewhat more so in arid countries, but not in the majority of places that do not have such industries to accept an income and labor force. And we see similar patterns on our proxy for urban
Perfect, so we have some time for questions before 1 o'clock and after 1 o'clock.
Right, I may have missed the detail, but it sounded like in the last version you were talking about, you're really looking for rainfall that's off of a trend. And if you had urbanization following some trend and rainfall following a trend, would you see nothing?
Yeah, you see nothing.
see
So
nothing.
for a linear city trend. So there's an overall, so I have one overall trend that's of arbitrary shape for the entire sample.
Right.
And
But
then each city
has
has its own linear trend.
linear trend, and so if by some chance, urbanization is just growing at a more or less linear pace, at least it's measured by lights, and if rainfall is just falling at a linear pace, then you would, in this model, you'd see nothing. You actually have to have
Yep, it has to be about, it
rainfall
has to be deviations.
is decreasing faster or something.
Yeah, or just blipping down 1 year at the same time that the lights are blipping down.
Could you say a little bit more about the big picture here in terms of urbanization and climate change and how you think this kind of research, does this make, is the standard line too simple and here you're showing it's more complicated? Is the standard line right? Is the standard line wrong? Should we be, is this one reason to be worried about climate change? Is that there'll be too many people living in the cities in some sense, or how does this relate to that?
So I mean, I think that, I think that the first thing you said is probably right, that, that it's a little more complicated than we expected, that we expect this in some places, not in others. And I think in the places we wouldn't expect it, that's not to say it's not a bad thing, it just kind of, as I mentioned, the story is essentially that everyone's really getting hurt, and their response to that just isn't necessarily moving to a city, right? So it's definitely not saying not to be worried in those places. It's just to say that the response is may differ depending on what one can find in the city one might move to.
And then I have just kind of a pedagogical question in terms of, when we do an analysis and we find no main effect, and then we do an interaction effect where the sum is 0 for half of our sample or some big part of our sample, but the two things separately have lots of stars on them. Is this okay, or should we be worried about that kind of procedure for doing the analysis? I mean, it just sounds to me, it's something that happens all the time. We have an idea, we do our research, we find no main effect. Oh, maybe if we start chopping this up. And then the fact that the sum is 0 for a lot of the sample, it just makes me very worried. And so but you seem to be careful about it. You seem to be thinking about, oh, we do this experiment on other types of heterogeneity, we don't see the effect. So therefore, and this was the first thing we looked at, so maybe we can believe it. Just some.
Yeah, I think that's a fair. I think that's definitely something to be worried about, and to let you all judge whether we're running afoul of that. I think that I'd say there are two things that I hope are disciplining in that. So one is theory, right? So one is that this is what we're looking for, right? And the other is that looking for other kinds of things that might matter. So much as you said, right? That I think that if we didn't have any theory to guide us, and if we just showed 100, if you run 100 interactions, you're going to 5 of them are going to be significant 5%. Okay, so that we wanted to worry about specification searching for that. I think I would argue that we were somewhat more disciplined than that in choosing the specification.
Hi, my name is Alicia Grace. Sorry I came in a bit late. I'm with the Oasis Initiative, which is a project of the School of Public. The Oasis Initiative, which is a project of the School of Public Health and the College of Natural Resources, focused on the Sahel. And this is from The Guardian last year. Population growth far outpaces food supply in conflict-ravaged Sahel. And this is from a study from Lund University. The Sahel, as you can probably speak to more than I can, has some of the most prolonged and earliest effects of climate change with the droughts in the 70s and 80s. As some of this, of course, region in Africa, the fastest growing, population will grow by nearly 3 times by 2050. And climate scientists don't agree. This is one of the last places in the world where they don't agree on what direction the precipitation is going to go. So meanwhile, there's a big effort to promote resilience to climate change and other shocks. And one of the strategies that a lot of governments are trying to implement is to encourage diversifying livelihoods, which for some means going into the city, and others, other types of agriculture, et cetera. So I see that your research doesn't have you haven't found big effects for the agricultural settings, but these are mostly rural smallholder farmers. So, but based on all of your reading, what would you say about this push to diversify livelihoods in the Sahel in the face of climate change?
I mean, I think, so that you packed a lot in there, and I think, one of the challenges of doing something across the whole region is that, there are important differences across sub-regions within it, right? But, I think that if we expect things to get worse, that having, diversification is going to be good. Yeah, I think that what our research is suggesting is that those diversification options have been somewhat limited over this time period, as perhaps the best way to think of it.
And do they tend to be the less industrialized countries as well?
So we're sort of, I'm saying that in a definition sense, yes, right? The places that we think one is less likely to find to sort of diversify in that way, we don't see as many people.
I was interested in the model where you had the interaction with wet versus dry.
Sure.
And I think that speaks a little bit also to this idea of resiliency, because presumably countries, can we go back to the model?
Yeah, I can try. The lights one or the population one? Actually, no, that's right. I didn't actually show it with the lights, so
Yeah, you had an interaction model.
That's right. Yeah. Here we go. Yeah.
Now maybe I'm wrong, but it looks as though there's what the implication is, to me anyway, that the very dry areas are the most vulnerable to the impacts in terms of the urbanization will be more pronounced.
So I think
Where that's possible, where it exists as an opportunity, which is your market measure.
Right, so I guess I think that's true. I think what I would just caution you is that the difference between the dry and the wet here is not significant. So that to the extent that we see a difference, it's noisily measured, I guess is what I would say. So yes, that we do see that, but this is, again, you could say sort of the hazard of setting up a regression like this, right? So that the sum of, so just this is our number for the drier places. Our number for wet places would be this plus this, right? And so the difference between the two is substantial, but noisy. So it points towards that, but
the only reason I'm highlighting it is that in relationship to this idea of resilience, because a place that's wet means that a diminishment of rainfall leaves it with some rainfall.
Right.
And there's some opportunity for crop switching or
Sure.
something else.
No, I think that's a good point.
A place that's dry, the diminishment of rainfall leaves you with no rainfall.
Right. I guess the other thing I'd say too is that the model we set up said sort of that this would happen, right? Because of the agricultural production function we chose. You could imagine the opposite effect, right? That places that have more rain are already more agriculturally intensified, and places that are very dry, to the extent anyone's there, they're doing something else. There's more.
Well, there may be possibilities, but
Right.
where animals die
Right.
because there's no rain, that leads to the same.
No, that's true. I'm sorry. I'm thinking of more sort of not. It could be that the few people there have non-agricultural or more like a non-agricultural livelihood. But I think that. But no, I think you're right. Our results are tending towards that. They're just.
Questions? Let me just ask a last question. If we want to work with lights, is this public data or do we have?
Yep. Yeah. So this is all the lights. So it's a 1 kilometer. So it's a nominally 1 kilometer grid squares. So 1 billion of them per year over what's now a 21-year panel. And there's a newer version that's sort of more refined, but I'm happy to talk to anyone about where the people who choose them. I'm happy to talk to anyone about that if they like.
All right, thank you very much.